In this video, we're going to work example problems where we solve equations and inequalities graphically. So if we take a look at this first example, we see that for each of these equations and inequalities, the expression on the left side is 2x plus 4, and the expression on the right side is minus x plus 1. Now this first example is simple because we can see each of these are linear, and we know we can solve a linear equation or inequality very easily using the properties of equations and inequalities, adding, subtracting, multiplying, dividing things on both sides. But if we think about this graphically, then what we can do is, since each of these are in one variable, then we can think about the expression on each side being a function of, so since we're in one variable, then we'll go up one to being a function of y. You go up one variable to the next variable that's not present in the equation. So we can think about the function y is equal to 2x plus 4, as well as the function y is equal to minus x plus 1. And so since that function is in two variables, we can plot that in the xy plane. And so that's what they do here. They plot y is equal to 2x plus 4 in the xy plane. So we know that's a line with slope 2 and y-intercept 4, and there's that line. They also plot y is equal to minus x plus 1, which is going to be another line with slope minus 1 and y-intercept 1, and there's that line. And so now with these two functions plotted, we can answer any equation or inequality between these two functions graphically. So if we think about the equation first, then the solutions, the solution or solutions to the equation are going to be where the two graphs intersect. And this makes sense because there's two criteria to have a solution to an equation. There's two criteria. The first criteria is you have to plug the same x value into both sides. You can't choose separate x values, right? It's the same, like you just choose an x value, you plug it into both sides. The second criteria is that you have to, the expression on each side needs to simplify to the same value. So we can't just plug in, if we plug in this x value here, x is equal to minus 3. Okay, you plug that into both sides, that's fine, but you simplify the left side, you get minus 2. You simplify the right side, you get positive 4. That's not a solution. Okay, so you could plug in x is equal to minus 3 to the right side, and x is equal to 0 into the left side, and you simplify and get the same value on both sides. So it's like the equality holds, but that doesn't count because you plugged in different x values into each side. So it's only going to be where they intersect, because in that case, you're plugging in the same x value to both sides, and when you simplify, you get the same value on both sides. That's a solution. Okay, so now with lines, we're only going to have one solution with two lines, unless they're like overlapping lines or something. But in general, as we know, when you have a linear equation, it's one solution where they cross. Okay, and so the solution is, we can see the solution to this equation is, we're looking for an x value. That's x is equal to minus 1. Because you plug in x is equal to minus 1 into both sides. Into the left side, it's going to simplify to 2. You plug it into the right side, it's going to simplify to 2. Okay, but now when it comes to an inequality, we can solve these graphically as well. So we're just comparing 2x plus 4 to minus x plus 1. Where is 2x plus 4 less than minus x plus 1? Well, we can see that's all in this region here. 2x plus 4, the blue curve, is always less than minus x plus 1, the red curve. That's anywhere where x is less than negative 1. 2x plus 4 is less than minus x plus 1. That's the solution. Okay, where is 2x plus 4 greater than or equal to minus x plus 1? Well, that's anywhere over here. That's going to be where x is greater than negative 1. Or no, greater than or equal to. Because it includes an equal. So at negative 1, they're equal. Okay, let's look at another example. So we've got minus 3x plus 1 on the left, and there's minus 3x plus 1. Y is equal to minus 3x plus 1. And minus x minus 3 on the right. There's y is equal to minus x minus 3. So the solution to the equation is, we can see x is equal to 2. because if you plugged in x equal to 2 to both sides, they're both going to simplify to minus 5, the same value. Okay, when is minus 3x plus 1 greater than minus x minus 3? Well, that's anywhere where x is less than 2. Okay, when is minus 3x plus 1 less than or equal to minus x minus 3? It's anywhere over here when x is greater than or equal to 2. Okay, so here's another example. We could simplify this. We could easily solve these using the properties of equality or inequalities, but let's do this graphically. So they don't give us a graph in this case, but we can use our calculators. We can use whatever. So I'm going to plug into Desmos. One graph is going to be this here, and another graph is going to be this here. Okay, so the blue is minus x plus 5, and the red is the minus 3x plus 2 plus 1. Okay, so there's where these are equal at x is equal to minus 5. Okay, where is the red curve less than or equal to the blue curve? Well, anywhere over here when x is greater than or equal to minus 5. Okay, now when is the red curve greater than or equal to the blue curve? Anywhere over here when x is less than or equal to minus 5. Okay, what do we do here? Well, it's the same idea, except we've just got some nonlinear expressions on both sides. But each side is just an expression of x. These are equations and inequalities in one variable. So we're just going to plot the function y is equal to 2x cubed minus 1, as well as the function, as well as this function. We'll have these two separate functions, and then we'll just look at the graph. So I'm going to plot these in Desmos. Okay, so this is 2x cubed minus 1, and this is root x, or square root of x minus 3x plus 4. Okay, so if we look at the equality first, there's only one solution we can see. It's going to be one solution here. It's very close to 1, but I plugged this into the calculator. It's 1.109. Okay, but now what about this inequality? When is 2x cubed minus 1 less than or equal to the square root of x minus 3x plus 4? Well, okay, we can see it's in this region. But we're not going to say over here, because this function doesn't even exist over here. At least as a real number, it doesn't exist. Meaning if we plugged in minus 4, well, okay, but you can't even evaluate it. So the domain of these equations is only when x is greater than or equal to 0. So we can see that the answer to this question, this inequality, part B, is when okay, so yeah, x is less than or equal to this 1.109, but greater than or equal to 0. Okay, now what about the greater than? Well, okay, we see that's over here. So that's going to be x is greater than 1.109. Okay, for this last problem, you can see we've got equations and inequalities in two variables, x and y. So just note that all of the previous problems we just worked, it might seem like these equations and inequalities were in two variables, but in actuality, they were all in one variable. We just extended it up to y for the purpose of making the expression on each side a function. So we had y as a function of x, so we could graph the function. But still, even with that, we were still just solving equations and inequalities in one variable. But here, we've got equations and inequalities in two variables. But we can still use the same concept to analyze and solve these. Because on each side, we've got an expression in x and y. So we can think about, in this case, having z as a function of x and y, and analyzing a graph in a 3D Cartesian coordinate system. So you have any point in the xy plane, any xy coordinate, you come to that coordinate, you plug that into the expression, simplify, get a value, and then you go up or down if it's positive or negative in the z direction, and that's the point. Okay, but now as we go past an equation or inequality in just one variable, things can get more complicated. So it's going to be a lot simpler to bring all of these terms to one side of the equation or inequality and have the opposite side equal to 0. So let's go ahead and do that. Okay, so now let's use Desmos, 3D Desmos, and plot this expression of x and y in the 3D Cartesian coordinate system. There we go. There's this expression here. Now, first, just note that when you look at this graph, it might seem like there's certain xy values to where there's no graph, but this is a polynomial expression in x and y. So you can input any xy pair and you're going to have an output. It's just that to get a good visual of this graph, we could only, the z-axis is only going from like 4 to -4. So, but if you input this xy pair here, then you're going to, so this is going to be in the negative range, but the graph's going to be way down here where you can't see the graph. But there will be, there is a graph there, okay? But now, to answer, if we start with the equation, to answer this equation, you can see we're looking for where this graph intersects the xy plane. That's when z would be equal to 0. And we could see it's in these regions here, all of these xy pairs. If you input any of these xy pairs into the equation, it's going to solve the equation, which means it's going to solve this original equation. Okay, now we can also see that when in regards to the inequalities, that if you're outside or inside this crossover region, the curve's going to be below the xy plane. And then if you're inside, it's going to be above the xy plane, inside this crossover point. And so those are these are all the xy pairs where the graph is greater than 0. And these are all the xy pairs where the graph is less than 0. And so really what you need to determine here, the first step, if you're going to answer the equation or inequalities, is what are these points, the crossover points? So if we take a look at this graph, looking straight down the z-axis, we get a much better view of this crossover, where the graph equals 0, where z is equal to 0. And we're not going to go into the full solution of a problem like this here in this video, because it's beyond the scope of this video. But I just wanted to go ahead and show you this just to give you a sense for a feel for analyzing a problem like this. But this is going to be this is a hyperbola. This is a hyperbola, and so this all of these xy pairs here that satisfy this equation, or that's what corresponds to this hyperbola. So this is going to be the equation for a hyperbola. You just need to put it into the form of a hyperbola. But we haven't talked about hyperbolas yet officially, so we're not going to do that here. But that would be the idea. The answer to this equation would be a hyperbola. And so that would be the answer to this equation. All of the xy pairs that lie on this specific hyperbola. And then this inequality would be all of the xy pairs that are inside the hyperbola. And this would correspond to all the xy pairs that are outside of the hyperbola. So that's the idea of how you look at solutions to an equation or inequality in more than one variable from a graphical standpoint.